Hello, cosmic explorers, and welcome back to the channel. I'm Ray Tayson, and tonight we're taking a close look at the stars in our own cosmic neighborhood. These aren't just distant points of light, they're suns, each with its own story and secrets. From binary stars to red giants and planetary systems, our local stars are anything but ordinary. So, dim the lights and get ready for a whirlwind tour of the most fascinating stellar neighbors in our corner of the Milky Way. With a touch of sci-fi and gothic flair, let's blast off. Our first stop is Alpha Centauri, just over 4 light-years away, our closest stellar neighbor. But Alpha Centauri isn't a single star. It's a complex family, with 3 stars, A, B, and Proxima Centauri, the closest to our Sun. This system is more than just a neighbor. It's a potential destination for humanity's first steps beyond the solar system. Alpha Centauri is actually 2 stars, Alpha Centauri A and B, locked in a binary dance. Imagine 2 suns orbiting a common center of mass, circling each other every 80 years. Alpha Centauri A is a G-type star, much like our Sun, while B is a smaller, cooler K-type star. If you lived on a planet here, you'd see double shadows and experience seasons shaped by 2 suns. And then there's Proxima Centauri, a distant red dwarf orbiting far from the main pair. Most stars in the Milky Way aren't loners like our Sun. Binary and multi-star systems are the norm. Our solar system is actually the oddball. So picture 2 suns, one yellow-white, one orange, waltzing through space with a faint red dwarf lurking on the outskirts. Planets here would have double sunsets and a sky unlike anything on Earth. Alpha Centauri is a living example of the galaxy's diversity. It's not just our neighbor, it's a stellar performance right next door. The universe is full of surprises, even in our backyard. Let's continue our journey to the next remarkable star. The cosmic dance continues, onward to Barnard's star. 6 light-years from home, we find Barnard's star, a red dwarf famous for its speed, not its brightness. It's so faint you need a telescope to see it, but it's the fastest-moving star in our sky. Barnard's star zips along at 142 kilometers per second, crossing the sky faster than any other star from our perspective. In about 10,000 years, it'll briefly become our closest neighbor. Red dwarfs like Barnard's are the marathon runners of the cosmos, living for trillions of years. For decades, astronomers debated whether it had planets. Some claims were disproven, but the search continues. Barnard's star is a lesson in patience and the scientific process. It's a quiet ember, enduring long after brighter stars fade. Even the faintest stars have stories worth telling. Let's move on to a true celebrity of the night sky. Next up, Sirius, the dog star. The cosmic spotlight shifts. At 8.6 light-years away, Sirius is the brightest star in our night sky, known as the dog star in Canis Major. Twice the mass of our Sun and 25 times more luminous, Sirius dazzles from ancient myth to modern science. But Sirius isn't alone. It has a secret companion, Sirius B, a white dwarf. Astronomers noticed Sirius wobbling, hinting at an unseen partner, finally discovered in 1862. Sirius B is the collapsed core of a once massive star, now the size of Earth but as massive as the Sun. A teaspoon of its material would weigh tons on Earth. White dwarfs are stellar ghosts, no longer fusing atoms, just glowing from residual heat. The Sirius system offers a glimpse into our Sun's distant future. In 5 billion years, our Sun will become a white dwarf too. The dog star and its pup are a cosmic memento mori, a reminder of the life and death of stars. They're a beacon in our sky and a profound lesson in stellar evolution. Now let's meet another star with a hidden companion. Meet Procyon, the little dog star in Canis Minor, 11.5 light-years away and the 8th brightest star in our sky. Like Sirius, Procyon is a binary system. Procyon A is a white-hot F-type star nearing the end of its main sequence life. Astronomers detected a wobble, leading to the discovery of Procyon B, another elusive white dwarf. Procyon B is even fainter than Sirius B, making its discovery a triumph of astronomy. It orbits Procyon A every 41 years. This system is a living laboratory for stellar evolution, a star nearing its giant phase, orbiting a companion that's already completed that journey. The universe loves repeating its favorite tricks. Two of our brightest neighbors both have white dwarf companions. These systems confirm our models of how stars live and die. They're not just points of light, but classrooms in the sky. Let's travel to a system that's famous for its planets, not its stars. Next stop, TRAPPIST-1. The search for life continues. 40 light-years away in Aquarius, TRAPPIST-1 is a tiny, dim red dwarf, but it's famous for its planets. In 2017, astronomers discovered 7 Earth-sized rocky planets orbiting this star. Several of these worlds are in the habitable zone, where liquid water could exist. The entire system is so compact, it would fit inside Mercury's orbit. If you stood on one planet, others would loom large in the sky. Life here would be very different. Perpetual red twilight, and likely tidally locked worlds with permanent day and night sides. The most habitable regions might be the twilight terminator zones. TRAPPIST-1 forces us to rethink where life might arise. Maybe not around stars like our sun, but around these ancient red dwarfs. We've only begun to scratch the surface of planetary discovery. The universe is full of surprises. Let's visit a star that shows us our sun's future. Onward to Gaykrux, the red giant. In the Southern Cross, 88 light-years away, lies Gaykrux, the closest red giant to Earth. Gaykrux has finished burning hydrogen and has swelled to 84 times the sun's radius. If placed in our solar system, it would engulf Mercury and nearly reach Venus. This is a preview of our sun's fate in 5 billion years. Gaycrux's reddish hue comes from its cooler, expanded surface, yet it shines with the light of 1,500 suns. It's also a barium star, enriched with heavy elements, evidence of a past companion that polluted its atmosphere. The white dwarf remnant of that companion is now too faint to see. Gaykrux is a living record of stellar evolution and mass transfer. It's a magnificent sight and a profound astronomical lesson. The story of stars is written in their light and chemistry. Now, let's meet a star that's spinning itself into a new shape. 25 light-years away in Lyra, Vega is a brilliant blue-white star and a true cosmic speedster. Vega spins on its axis in just 12.5 hours. So fast it bulges at the equator and flattens at the poles. Its equator is 23% wider than its poles, making it an oblate spheroid. If it spun much faster, it would start to tear itself apart. This rapid rotation causes gravity darkening. The poles are hotter and brighter than the equator. Vega was the first star after the Sun to be photographed and have its spectrum recorded. It's a benchmark for astronomers and a fixture in science fiction, famously featured in Vega is more than a pretty light. It's a laboratory for extreme physics. Even a star's shape isn't always a perfect sphere. The universe pushes the limits of physics, even in our backyard. Vega is a spectacular example of stellar extremes. Our tour is almost complete. Let's reflect on our place among the stars. Our tour of the cosmic neighborhood ends here. We've met binary stars, red giants, white dwarfs, and planetary systems, all sharing our corner of the Milky Way. These aren't just distant objects. They're part of our extended home. The universe is full of wonders, right here, waiting to be discovered. Which cosmic neighbor surprised you most? Let me know in the comments. Thanks for joining me. Don't forget to like, subscribe, and ring the bell for more cosmic journeys. Until next time, keep looking up, and may your nights be starry and a little bit gothic.